The weather map helps to predict the location where a storm will occur by giving which type of information. So when you look at this weather map, you can see a couple things. Let's look at this one on the side. You can see this blue thing right here with the little triangles. That's a cold front. And you can see right here we got a warm front. And if you really want to be fancy, what's probably going to happen here is something called an occluded front when this cold front comes up and captures this warm front. What else you can see on this weather map, though, is an L and an H. The L stands for low pressure, which is usually associated with bad weather, and the H stands for high pressure, which is usually associated with good weather. So those are basically the only information you can get off of either of these maps. And so when you read your choices, can you get information about air pressure? Yeah, you can see the highs and the lows, and you can even see the actual pressure on these little millibars, like 1,008, 1,992, because these are counting by eighths. Can you tell the humidity on this map? Nope, not at all. What about the wind speed? Nope. What about the temperature? Nope, not at all. So the answer is A, air pressure. So a low pressure system has moved away from the equator and is moving directly over water. When the system reaches 60 degrees north latitude, the system will most likely be at a point where? So a low pressure system moved away from the equator. What this question is kind of trying to sneakily ask you here is, this low pressure system they're talking about at the equator is similar to a hurricane if it is not in fact a hurricane. So the first thing you need to understand is, what does a hurricane need? And that question should be answered with warm water. So hurricanes, if you look at this map over here, hurricanes are only basically found just north and just south of the equator. At 60 degrees north, we're up here just below Alaska and a little above Great Britain. So this is a very, very cold area at 60 degrees north latitude. So the answer to this question is most of its energy will be lost, D, because a hurricane can't survive without water temperatures that are at least close to 80 degrees. So the answer is D, most of its energy is lost. A scientist is studying energy transfer that occurs in the ocean's atmosphere and Earth's interior. Which of these is the scientist most likely studying? So, energy transfer in the ocean, that's energy being transferred through a liquid. Energy transfer in the atmosphere, that's going to be energy transferred in a gas. And the Earth's interior, believe it or not, that's also going to be energy transferred in a liquid. So which of these is the scientist most likely studying? If you look over here at this diagram, what we're basically talking about is energy that's really, really hot. Hot things rise, so heat rises, and as it rises, it cools. And then cool things descend or sink. And this cycle goes around and around and around. And this question is kind of easy because it really only gives you one option. Energy transfer can only be one of three things: conduction, convection, or radiation. And in this case, the energy being transferred through a liquid or a gas is called convection. Cloudy nights can be warmer than clear nights because clouds trap heat generated from the tropical winds, produced by the friction of air particles, released from the Earth's interior, or absorbed by the Earth during daylight hours. This is a tricky question because it gives you a couple choices that seem to make sense, but make sure you always remember these questions are asking for the best possible answer. And two things. First, cloudy nights do make the air temperatures warmer because they keep all the Earth's heat in. If it's really clear at night, you can expect temperatures to drop more significantly than if it was a very cloudy night. And that works the opposite during the day. During the daytime, if it's not cloudy, we get much more of the sun's rays that will hit the ground and will warm the ground, and then through convection will warm the air. So the best answer here is all of that heat that these clouds are trapping are coming from The sun and the sunlight that was absorbed by the earth during daylight hours. So your best answer here is J. Which of these most likely occurs after moist air is cooled below its dew point? Well, you have to understand what dew point is, and you have to understand that dew point is a temperature. Dew point is the temperature at which the atmosphere would be completely saturated or full of water. So think about it as a really warm atmosphere is very large, and a very cold atmosphere is significantly smaller. So as you cool the atmosphere itself will shrink, and as it shrinks, all of that water in it can eventually get kind of wrung out like a really wet sponge. So dew point, remember dew point, the most important thing is it's a temperature. So if you quickly, or even over time, but usually quickly, if you quickly cool the atmosphere and all of a sudden the atmosphere becomes completely saturated or full of water, water will change. It will change from that water vapor that it is in the clouds and in the sky to liquid water. And remember, when you change water from a gas to a liquid, that's called condensation. So our best answer here is A, water condenses. All right, and remember B, evaporation. That's the opposite. That's when we go from a liquid to a gas, like if you were boiling a pot of water. And even if you didn't know any of that stuff about this question, try to think of, just in your mind, what dew means. And you know what dew means in the mornings. You live in Virginia Beach. And it just means water condenses. Dramatic variations in the polar ice caps most likely suggest changes in the moon's orbit, the Earth's climate, the ebb and flow of tides, or the global water consumption. So what the question is talking about here is the significant loss of our glaciers in the ice caps, the north and the south. So what's the most likely cause of this significant change to how much ice we have at our poles? It has nothing to do with the Earth's orbit. The Earth's climate, which is the overall, global weather patterns over a period of years, well, if it's getting warmer on the Earth, we would have less ice at the cap, so that would be a good answer. The flow of the tides, no, that's not going to be a major contributor here to ice cap melting. And global water consumption, we don't drink the ice caps. So our best answer here is the Earth's climate. So this is a question regarding climate change and the Earth raising temperatures, which is going to decrease the amount of ice in the North and South Pole. The label L indicates an area of low. I think this will be an easy question for everyone, but if you remember on weather maps when you see H's and L's and you see these isobars right here, which are going to tell you the air pressure, then you know this is L is an area of low pressure, letter B. Just don't forget a little information about low pressure. When you do have a region of very low pressure, that means the air is generally rushing into that area, and you're going to have a counterclockwise rotation. Low pressure areas are very unstable. Because of this area of low pressure, you get a lot of warm air rising, you get clouds, you get rain, you can even get really terrible conditions such as hurricanes. So based on the changes between the weather conditions, which of these most likely pass by the weather station between time 1 and time 2? Well, let's look at our chart here. Conditions at time 1, we have a temperature of 30 degrees Celsius, but at time 2 the temperatures drop to 25 degrees Celsius. The air pressure goes from a region of lower pressure to a region of higher pressure, meaning the weather should have improved, should be nicer out. The wind direction was from the south, and now the wind is coming from the north. So basically this is a real standard situation here in Virginia Beach where we have the continental polar cold dry air mass behind us, And then we got the warm maritime tropical air mass coming from the south. In this situation, it appears that the cold air has won the battle and it has pushed through because our conditions now are colder and they're from the north. So most likely what passed through here was C, a cold front. Release of CFCs, and remember CFC stands for chlorofluorocarbons, and similar compounds are a possible cause of, this is definitely just a memory question, if you can remember from class what chlorofluorocarbons affect greatly, and that's the ozone layer. That chlorine molecule can go up and it can take that O3 ozone molecule and it can break it down into an O2 and an O. So the best answer here is F, a destruction of the ozone in the upper atmosphere. And do you remember what layer of the atmosphere the ozone layer is in? Hopefully you just thought stratosphere. That would have been your best answer. Look for a question on the SOL that's it's worded a little bit tricky, but it's always a really simple answer. So, which of the following was primarily responsible for the development of life outside of the oceans? Anytime they have a question about the importance of life on the earth and how it came to be, your answer is always going to be one of two things. It's going to be either oxygen in the atmosphere or it's going to be liquid water. So in this case right here, our best answer here is an increase in atmospheric oxygen, J. So don't overthink these questions. There's always one of them. Similar question. Remember, whenever you see a question that's asking you about life flourishing or the most important elements to life in the earth, always look for oxygen or water. Which element in the Earth's atmosphere is essential for human life and is extremely rare or non-existent in the atmospheres of other planets in our solar system? And our best answer here, again, is oxygen. Ozone molecules protect the Earth from the harmful effects of the sun by, well, you just got to remember what this ozone, which is 3 oxygen molecules bonded together, is important for. And its importance in the stratosphere here, the ozone layer, its importance is absorbing the harmful radiation, the ultraviolet or UV radiation from the sun, and protecting our planet and us. So, our best answer here, A, insulating the temperature at the poles? No. B, condensing water particles in the clouds? No. Regulating the heat from the sun? It's not a bad answer. They try to do this a lot in the SOL. Be sure you always read choice D, which is absorbing ultraviolet radiation. So D is a much better answer. People have tried many methods to artificially produce rain. One method, called cloud seeding, involves airplanes dropping particles of silver iodide onto clouds to help the clouds produce rain droplets. These silver iodide particles act as, this is a simple vocabulary question. Can you remember what the term is for particles of dust and dirt and debris that are up here in the atmosphere that water vapor bonds to, so your water molecule will bond to it and form a cloud? If you remember that, this question's easy and you will choose D, condensation nuclei. So clouds basically only really need 2 things. They need warm, moist air ascending or rising. So if you have that warm, moist air rising and you have some particles of dust or dirt or debris for the water to bond to, you'll make clouds. And this bottom picture here is an airplane that is cloud seeding. Alright, right here we have a sea breeze and a land breeze question. And the question basically asks, Why in the daytime do we have a sea breeze, which means the air is coming off of the water onto the land? And why at night do we have a land breeze, which means the air is coming off the land out to the water? Now, this is a complex question, but if you think about it, you should be able to come up with the answer. And the first thing you need to realize is during the daytime, the land is going to get hotter than the water. So as the land gets warmer and warmer and warmer, that warm air is going to rise up, because that's what warm air does. As that warm air rises, you create an area of low pressure here. That area of low pressure is going to quickly get filled from the area of high pressure, because air always moves from high pressure to low pressure. So we're going to create this situation where we have air coming from the water to fill this area of low pressure, and it goes around and around and around. At nighttime, we have the opposite effect, because at nighttime the land cools quicker than the water, so we'll have lower temperatures here in the land than we will over the water. That's going to create a low pressure here, where we're going to have warmer air above the water that's going to be rising. That's going to get filled with this cooler air of high pressure, and the air is, once again, is going to go from high to low, and this is going to go around and around and around. So what would explain the change in the direction of air movement from daytime to night? Water is always cooler than land? It's not true, because at nighttime the water is usually warmer than the land. G, land temperature changes more quickly than water temperature. Okay. Cool air rises more quickly than warm air, and we know that's wrong. The sun warms the moist ocean air more than the dry land air. We know that's wrong. So our best answer here is G. The land temperatures change more quickly than the water temperatures, because the land is nice and hot during the day when the sun's hitting it, but cool at night when the sun is no longer hitting it, and our ocean has a more stable temperature. Rainforest is found at the base of Mount Kilimanjaro in Africa. Remember the base I'm talking about down here. So we have a rainforest. And the summit, remember the summit is the top of the mountain, is snow-capped. Which of the following would best account for this? So why would we have snow at the top of the mountain and a rainforest at the bottom of the mountain? Could it be A, temperature differences due to elevation changes? That makes sense. Climate differences due to seasonal changes? Differences in precipitation due to the formation of a rain shadow? Climate changes due to changes in latitude? There's a lot of questions, a lot of choices here that have some key words to them that would make you think that maybe it's the right answer. But try to make this real simple. Why is it snowing at the top of the mountain? Because it's colder up there. It gets colder as you climb to the top of the mountain. As you go higher in the atmosphere, the temperature drops at a very consistent rate. So our best answer here is the temperature differences due to elevation changes. A. Currents in the atmosphere. So first you have to stop and think to yourself, what do they mean here? What are currents in the atmosphere? Remember, a current is something that flows, something that moves in the atmosphere. What's our atmosphere? Our atmosphere is our air. It's our oxygen and our nitrogen. All right, and then some other things, but mostly a nitrogen and oxygen atmosphere. So really what we're talking about here is wind. What causes the air to move? And if you really think about it, this is a nice, easy question. What's causing our air to move? Convection, right? And that's our warm air rising. And then as it rises, it gets colder, and then it becomes sinking air. And then as it sinks, it gets warmer again. And then as it gets warmer again, it rises, and this goes around and around and around. So really what we're talking about here is convection, which is the heat transfer through a liquid or a gas. So our best answer of what causes the air to move: ocean waves or currents? No. Pressure from the ozone layer? No. Solar heating of the upper atmosphere? No. Warm air rising? Cold air sinking? Yes. The answer is J. Which of these is important in the formation of clouds? So remember, with clouds, you basically need two things. You need warm, moist air, and you need that air ascending or rising. So we need warm, moist air rising, and then we need something for those water molecules to bond to form a cloud. And we have a fancy name for that. It's going to be called condensation nuclei. So that's the two most important overall things you need for a cloud. So let's look at our choices here. The relative length of the day and the night? No. The Coriolis effect? No. The melting of the polar ice caps? No. Or the cooling of air as it rises. So when you get that warm, moist air ascending, it's going to cool, it's going to condense, it's going to bond to the condensation nuclei, you're going to get a cloud. The answer is J, the cooling of air as it rises. According to the map, most hurricanes occur where? Well, let's look at this map. And remember, what do hurricanes need more than anything? They need warm water. So if you see right here, we're at 0 degrees latitude, and you can kind of see just above it and just below it, that's where most of our hurricanes are. So a hurricane needs a center of low pressure to circulate, and then it needs warm, moist air to feed it and give it its energy. So according to the map, most hurricanes occur where? F, the oceans are the warmest. Yes, that is absolutely the best answer, where the oceans are the warmest. Moist air from the Pacific Ocean, over here, rises and cools as it passes from west to east over the Sierra Nevada mountains. Once it's over the mountain range, the air descends and warms on the other side. What is the result of the ascending then descending air over the mountains? Well, let's take a look. So on this side, we're going to have some moist air, and it's going to be rising. Remember, moist air is going to make clouds, and clouds are going to make rain. Now, when we go over the mountain range, the air is going to be descending. Sinking air never ever makes clouds. So on this side, we're going to be in a situation where we never have clouds and therefore never have rain. So are we going to have a desert on the west side of the mountain and heavy rains on the east side? No. Are we going to have heavy rains on the west side of the mountain and a desert on the east side of the mountain? Very likely. Are we going to have heavy rains on the west side of the mountain and year-round snow on the east side? A desert on the east and west side? No. So our best answer here is G, heavy rains on the west side of the mountain and a desert on the east side of the mountain. This is called a rain shadow desert. Which factor would best explain why Charlottesville, our top chart, is clear, but Norfolk has a mist? Well, let's look at our differences here. In Charlottesville, it's 23 degrees Celsius, and the temperature in Norfolk, 13 degrees Celsius. Okay? Our humidity is only 38%. Our relative humidity is 38% in Charlottesville. It's 89% in Norfolk. Our dew point, we're very close to our dew point here in Norfolk, and we're not very close to our dew point in Charlottesville. That's a good indication here, with the dew point being very low and our humidity being very low, that we have very cool, dry air here in Charlottesville. But in Norfolk, it looks like we have much more full atmosphere. So we have a very, close to a saturated atmosphere. We're not at 100%, but we're very close to saturation. So which factor would best explain why Charlottesville is clear and Norfolk has a mist? Mist meaning moisture. And our best answer here is not the temperature, but the humidity. G, the humidity. That's your best indication of why we would have a mist.